Happy Tuesday, everyone. I hope you've had a good Tuesday so far. Enjoying half your day off. Seniors, I know you made me proud on the work keys. Hope it wasn't as bad as ACT. It's not supposed to be. But what we're going to do today, what we're going to talk about now is our homework problems, our 6 homework problems. And we're going to go through these problems to make sure you understand what you're doing. Alright, so our learning target is still, I can determine the zeros of a polynomial. When I say determine the zeros of a polynomial, I mean all the real, all the complex, everything, okay? So let's look at now, I have this paper, it's page 23 in your notebook. We're starting with number 6. I'm going to work out a notebook paper so I have plenty of room. Well, I could have worked this one here, so let's just do this. Alright, on the first one I told you I would like for you to list the possible roots. So we're going to do that first. Remember, to find the possible rational roots, let me lock this in. You list the factors of the last term divided by the factors of the first one. So I'm going to do factors of 15. Plus or minus 1, plus or minus 15, plus or minus 3, plus or minus 5. Now I'm going to list the factors of 1. Plus or minus 1, that's it. So my possible zeros, you take all these and divide it by this. So I'm going to say 1 divided by 1 is plus or minus 1. 15 divided by 1 is plus or minus 15. 3 divided by 1 is plus or minus 3. And 5 divided by 1 is plus or minus 5. That's my possible. And it only tells you your possible rational zeros. It does not tell you your imaginary. You cannot determine that at this point. But this is just possible. If it's to cross the x-axis, I'm going to get one of those real possible zeros right there. Alright, so what we're going to do first, and the reason we do this, so we can know if our answers are reasonable. Okay, so what I'm going to do is graph this. And I find one of my zeros clearly at -3. So I'm going to make me a zero list. And I'm going to break it down. Put that number there. I have 1, 3, -5, -15. I'm going to bring this down. -3 times 1 is -3. It gives me 0, 0, Alright, so now I have my quadratic x squared minus 5. It's down to quadratic, set it equal to 0. Now this is easy, so I can move that -5. I can't factor that, but I can move that as a 5, and it's going to be x equals, when you take the square root of something, plus or minus 5. So my zeros are -3 plus or minus 5. Now guys, I want you to look at something. We did a long way on this one because if I look at this, let's go back and look at this function. Let's look at this function here. It's 4 terms. You know, you can always try factor. If it can factor, you don't have to do this long process. Let's look here. I can take an x out, x squared. That's going to give me x plus 3. Take a -5 out. That gives me an x plus 3. So I'm with x squared minus 5 and x plus 3. Well, that's what I kind of ended up with right here, wasn't it? X plus 3, that gives me -3, and that gives me plus or minus square root of 5. So always check. I should have checked to begin with, but that could be factored, so you didn't have to do the long process here. Now number 7. Number 7 is clearly, now going back, hold on, 6. We have 3 zeros here, and all 3 of these are real. There's no complex or imaginary. There's no complex solutions. So let's look at 7 here. I didn't tell you to find the possible on this one, but you can look at this and tell it's clearly factorable. That is a sum of cube. So remember, when you're doing a sum of cube, it's going to be small parentheses and a large parentheses. In the binomial, in this one right here, binomial, you can take the cube root of both of those. Oh, sorry. Sorry, let me just correct this. Cube root of x cubed is x. Cube root of 64 is 4. To get the first term of the trinomial, you square that first one, x squared. Multiply these two together and square the last one. Remember, you do signs at the end. So, same sign, opposite, always positive. Well, x plus 4 equals 0. X equals negative 4. So that's one of your zeros. So you can go and put that down in your list. Because we factored it, we didn't have to do the synthetic thing. We didn't have to do all the synthetic division. Here, that's quadratic. I can't factor that. But I can do the quadratic formula. Opposite of b, 4 plus or minus negative 4 squared minus 4 times 1 times 16 all over 2 times 1. 4 plus or minus 16 minus 64. All over 2, 4 plus or minus square root of negative 48 over 2. So we know we have some complex here. Okay, I can break 48 down. Watch this, 48. It's 12 times 4, 4 times 3, 2 times 2. I have a group of 2s, so 2 times 2 is 4. Now to combat that negative, I'm going to bring out an I. And here I can take a 2 out of all that, so my 0 would be 2 plus or minus 2i square root of 3. So my other 0 would be 2 plus or minus 2i square root of 3. So in this case, I have 3 zeros, 1 real, and 2 complex, because it has that imaginary component. 1 real, 2 complex. If I was to graph this, you would only see the negative 4. All right, let's look at number 8. Number 8, I look at that to see if I can factor. It's got 4 terms, but if I was to factor that, that would not give me the same thing in the parentheses. So, we are going to list the possible zeros on this one. Factors of 5, plus or minus 1, plus or minus 5. Factors of 6, plus or minus 1, plus or minus 6, plus or minus 2, plus or minus 3. Alright, I'm going to take each of these and divide it by this, each of these divide by 6, each of these divide by 2, each of these divide by 3. So my possible list, so I'm going to get kind of big, possible zeros. 1 divided by 1 is 1, 5 divided by 1 is 5. 1 divided by 6 is 1 6, 5 divided by 6 is 5 6. 1 divided by 2 is 1 half, 5 divided by 2 is 5 halves. So let's see what it did. 1 divided by 1, 5 divided by 1. 1 divided by 6, 5 divided by 6. 1 divided by 2, 5 divided by 2. Now 1 divided by 3, 1/3. 5 divided by 3 is plus or minus 5/3. So I have 2, 3, 4, 5, 6, 7, 8, really 16 possible rational zeros there. Alright, I'm going to make my zeros list. I'm going to graph this. (6x cubed plus 25x squared minus 24x plus 5). Okay, looks like it went through -5. I'm going to check my table just to make sure. I go up to -5, it does cross 0. So This is good. I go to -5. I go to -5. I do see 0 there, okay? So I'm going to put -5 down, and then I'm going to break this down, okay? 6, 25, -24, and 5. And I'm going to put -5 here. Bring the 6 down. -5 times 6 is -30. 25 and -30 gives me -5. -5 times -5 is 25. That gives me a remainder of 0. So now I have the quadratic, because remember I want to get it to quadratic because I could either factor or use quadratic formula. So I do have it at a quadratic now. It's got to multiply. Now you see if you factor it. You indeed can factor that. I'm going to come right here and factor it. So you got 6x squared minus 5x plus 1. Remember, do it the way you were taught. I do bust them up. So I factor this, set both of them equal to 0. I get 1/3 and 1/2. One-third and 1/2. And I look at my possible 1/3 and 1/2. Yes. So Mr. Trish, it only looks like it crossed the x-axis twice. Well, it did cross very closely together. It went a little under x-axis and came back up. So that's why you can't see it too well there. So those are your zeros for number 8. Remember, you can stop the video at any time to take your time and go back through this. All right, number 9. I look at number 9. I have 1, 2, 3, 4, 5 terms. I've never taught you anything with 5 terms. Can't take a GCF out, so I can't factor this. So what I'm going to do, I'm not going to do the possible zeros on this one. We're just going to find it, okay? So I'm going to put this in the calculator. Okay, it was an even degree, leading coefficient positive, so the ends are sticking upward. That's what it's supposed to be doing. Now, remember, this is a quartic. This was a cubic. You have to work it down to get to a quadratic. So I only had to do synthetic division one time to get it from cubic to quadratic, so I could work with it. Here, this is quartic. I'm going to have to break it down twice to get it to quadratic. So I need to locate 2 zeros. Looks like -1 is 1. If I check my table, -1 and 2 and 3, so I can put -1 and 2. So I'm going to use -1, and I'm going to break it down. I use -1 to break it down to, that's 3, -14, 13, and 6. And now I'm going to use the other 0, 2, to break it down again. So I'm going to put 3, -14, 13, 6, and use 2. To bring 3 down, 2 times 3 is 6, -14 and 6 is -8. 2 times -8 is -16. That gives me a -3. So now I have the quadratic 3x squared minus 8x minus 3. That looks like you could factor. So when I have to use quadratic formula, I'm going to come over here. Do it the way you were taught. My way, it's got to multiply to give you -9, add to give you -8. It's -9 and +1. Group it off. So x equals negative 1/3 and x equals 3. So with my zeros, I will put negative 1/3 and 3. As long as you have the 4, it does not matter what particular order, as long as you have the 4 zeros. That's how I found the other two. I used 2 to break it down to a quadratic, and then used the factoring to get the other 2. Looking at number 10, there's 5 terms. I can't take a GCF out of there, so I don't know how to factor that. So you can't factor that. So what you're going to use is you're going to graph it. Alright, what is a quartet function? I got to break it down twice. I see exactly 2 zeros. So my zeros, negative 6 and 5. I'm use my table to verify that. I see negative 6 there and 5, okay? So I'm ready to break it down. Remember to check all the degrees, make sure they're present. If they're not, you got to put a 0 in there. I'm going to use negative 6 first. Once you use it, you cannot use it again for synthetic division. So I got 0 there. That's good. Now I'm going to use the 5. Okay, now I get my quadratic x squared plus 4. Okay, it's quadratic. I can work with that. Set equal to 0. It's an easy type. You can just bring it over. It's negative 4. When you take the square root of something, it's plus or minus 2i. So you have 4 zeros there. 2 are real. You can see where that cross, and then 2 complex because they have that imaginary component. Okay, it's plus or minus 2i. Alright, we're going to stop there, and I'm going to go over number 11 in class tomorrow. I want you to be in class for me to go over that one. So make sure you start to understand that. And the main thing is check to see if you can factor first. If you can factor them, you do not have to do them long way. But like these, you cannot factor. You have to go about this process. So if you have any questions, I will write them down, and you can ask me tomorrow. Thank you.